Cool. Well, thanks for letting me talk. It should be a bit nerve-wracking. I do a little bit of teaching, but generally that's to a bunch of students that don't really know about the subject that I'm about to talk to. Whereas I feel like actually you guys probably know an awful lot more about all of this than I do. But nonetheless, this was my little kind of adventure in development. So I taught this my adventure with weather, a couple of Raspberry Pis, a bit of Node-RED, some MQTT, InfluxDB, Grafana, and a very little bit of Python and JavaScript. And my coding is nowhere near where I would like it to be, hence why probably more reliant on the other bit that at the head of that heading there. So kind of what have I done with Pis briefly? I've first played with them, I think this was probably back 2013-ish, something like that. Made a little SMS notifier, so just contact closure, and then managed to convince it to send SMS messages out of the little 3G dongle. I've also got one of these little tiny rovers. I've been lucky enough to work on some quite large scale outdoor events that have required kind of time-lapse footage of the build of the assembly of the event. So for quite a couple of years, I was putting Raspberry Pis in floodlights and butting them up in various stadiums around the world. And then the neat thing about this is it's quite easy to go and install an unobtrusive floodlight in the corner of a stadium while there's still sport going on for a couple of days and nobody really notices. But then when you come in and roll in with your big kind of theatrical event or show, you can then obviously you're already capturing the footage. That's quite cool. And one of the other kind of big projects that I was lucky enough to be involved with was a high altitude balloon project. We did a bit of a marketing stunt for a high street firm, basically placing the first bet from space, as they called it. If I run that little video again, and the payload in there was a Raspberry Pi and a UPS module, a GPS module. And we got it to do some stuff when we broke the 100,000 feet or 30 kilometers. So that's the kind of nonsense that I played with previously. But where did I want to go with this particular project? So I'd been looking at some time about doing some kind of value or metric type monitoring of basically performance monitoring of stuff. I'd looked at Microtext the Dude and used that on a fair number of projects, PRGT, SolarWinds, and various other SNMP monitoring devices. And that works to an extent for me, but it was quite convoluted and it didn't quite do what I wanted it to do. I was looking for something to give me kind of in a number of different projects, something that gave me basically a nice big green dashboard when everything was healthy, and not so if something was not right. So I kind of needed I thought I want to kind of work this out. So I needed a changing data set in order to try and utilize this monitoring for, or develop this monitoring idea. And this was kind of early on into the first lockdown. Everybody sat at home, looking out the window, and the initial thing that got me thinking is, we're actually on the flight path here, West London. So I thought, actually, what's happening with the air pollutants? What's going on with the air quality? I thought that would be a great thing if I could put something together that would allow us to kind of track what had gone on with what had happened with air quality during this whole period, what changed. So I thought, right, basically going to be building a weather station is kind of where this is going. Now I've got a little bit of history of that. On the same number of these similar projects, these large stadiums, we would quite often have either kind of performers flying at height. We'd have large scenic pieces that might blow over, or you certainly can't fly when it's blown a gale or blown a storm. Or we might just have, people, riggers, whatever, working in exposed areas. So if the weather conditions were such, we'd obviously have to close the roof or close those exposed areas. And I'd used the Davis Vantage View stations quite a lot. This one's Glasgow on the Celtic grounds. This one's on the rooftop of our offices in Mexico, and this is the top of the LED screen, which was actually a really poor screen. Actually, I think people's old CRTs probably actually look better than that one. But the and then just put one on a bit of layer scaff at the top of that in the Shark Stadium in Veracruz, Mexico, to basically give us a report back on the wind. That's all great, but obviously every time you want to measure the wind, you have to drop one of these sensor stations down there, and perhaps we might want to monitor the temperature at different locations. And perhaps I'm not concerned about the wind direction, I just want to know the wind speed. So I thought that these are great, but they don't really give me the kind of granular ability that I want to do. And also each one of these sensor station requires a remote station to push that data back down to, and then that needs a network connection. So as you can see, it all gets quite messy quite quickly. So I thought there's got to be a neater way to do this. Now I've messed around with Raspberry Pis, put in little temperature units into those and that kind of stuff. And actually I reminded myself that I had read the build your own weather station from the Raspberry Pi projects page couple of dozen times, and also there's been a couple of articles in the Magpie over the years about similar things. So it all been kind of out there and read it a good couple of times. And I'd also I found on my in my kit of parts that for a while now I'd had this Pimoroni Enviro unit. So I was like, actually this is great. This has got to be a good start for where we want to go. But what I'd really struggled with to kind of lay my hands on or work out how to achieve was the weather vane and the anemometer. The rest of the components of that's quite easy, but back re-energizing this project at the beginning of lockdown and kind of looking around online for bits and pieces, I stumbled across the SparkFun kit that kind of was designed, what this kit, the original project was built around, available at CPC for not an unreasonable sum of money. And I thought that's great. That gets me my rain bucket, my anemometer, and my weather vane. And as I don't have access to don't have a 3D printer here, how do we set about doing this? So I was like, right, this is great. I've got the main lumps. How are we going to kind of plug this all together and set about making it work? Now I do love a good drawing myself, so I sat down with Fritzing and basically started to map out how I was going to make this all work. I took that original Raspberry Pi projects as a base, as a start for 6, and then added a few other bits and pieces. You can see here there's a precipitation sensor, microphone, and a UV sensor to kind of take that on a little bit. Now my original plan was the kit was going to be all mounted up high on, so the weather vane and the anemometer would be kind of as unobstructed as possible by the house, and kind of similar to what I'd done with the teams on these kind of stadium shows, is you just get it nice and high. I thought I'll put it up on the side of the house. That would be great. Clear the obstacles. So I wanted to make it PoE powered, so I could just drop the Pi probably in my loft and then just run a bit of wire outside for the exterior sensors. The original project uses a DS 18B20 to do the ideally to do the moisture reading from the soil was the original plan, with that kind of schools education kit. I was going to put this at the top of my house, not a lot of soil up there, so I thought what I'll do is I'll swap that out for the DHC22 and pop that inside my loft, and that would give me a reading from in there. So I thought, right, this is a good plan. This has got legs. It's going to work. So I kind of, in tandem with this drawing, set about kind of building it all on a big bit of breadboard. The added in the UV sensor here, did these on a little kind of satellite daughter board, because this generally lived under a plastic bucket outside my house, and then I wanted to put the temperature sensor and the UV sensor in somewhere that was a bit more exposed, so it could get a bit of daylight on it. So and there's just yeah, these sensors come down on they ship with RJ11 cables, and then there's just a bit of 2-core copper up to the what is that, the precipitation sensor. So I'd pretty much followed that original plan of the guide, with a few deviations from that along the way, and I'd got it all kind of running from the command line, but I wanted to try and aggregate that all together, and I wanted to keep it flexible. Now, as I mentioned, sadly my Python coding is not kind of where I wanted it to be able to kind of assemble all this off the bat and be able to change that and view that and debug that along the way quite simply. So I wanted to use a thing called Node-RED. I don't know whether that's something that's kind of featured here before, but basically, so I have been dabbling with some other bits and pieces, doing some other little projects based around Node-RED, and I just really enjoyed that environment. I really liked what it could do, how it all worked, and the kind of the flexibility and the power that gave. So here was my vision of how it was all going to work. I was going to have one of my old trusty Pi Model B versions that I think had actually been a Raspberry a time-lapse camera on a large production that you might have seen on one of your TV screens, a few years back. Going to put that in a little box outside, strap all the sensors into that, run Node-RED on that Pi, probably develop a Node-RED dashboard. And at this point in the adventure, I was kind of seeing the Node-RED dashboard as being the ultimate presentation of how this was all gonna work. The plan was then that I would push that center matrix data across to my Pi 4, lives under the cupboard under the stairs, running Mosquito to receive that MQT data, because I also wanted the ability to aggregate perhaps another Pi with another series of sensors, or other sensors from other devices into here, and then along this journey, a good friend of mine from my work kind of pointed me out to this whole Grafana thing, and what that was all about. And I'd kind of begin looking at that, and the Grafana dashboarding experience, and being able to take that raw data and present something into something really quite attractive to look at and quite powerful to look at, was super easy. The other nice thing here was the Node-RED dashboard, or kind of the downside of the Node-RED dashboard. Any kind of graph data that you build in here gets zeroed out when you change your Node-RED profile, or update your flows, or reboot the Pi. Yes, you could write all that down to a CSV, and then you could read all that back into into your dashboard, but that was all quite clunky. Whereas this whole flow of Influx and Grafana was great. And right back to my original intention here was, ultimately I wanted to build that nice big GUI dashboard and be able to monitor lots of different data. And I thought this is it. These are the building blocks to achieve that. And it also meant that I could aggregate lots of different stuff into that. Let me just check that I've not missed anything. Cool. So how did I I've just got a quick little video here for anybody that's not seen Node-RED before. A super little kind of me building a little thing. This is just Node-RED running on the same on the Pi that's running the weather station data. We just drop an inject node. We drop a temperature sensor node that's got that ships with Node-RED when you install it. If you add all in the Pi details, I got it set to pin, physically connected to pin 7. So map that all in, deploy it, hit the button, and bosh, it's 8.10. Actually, 8.10 degrees Celsius is what that was reading. But that little RPI DHT module will spit out a boatload more data. So if we look at everything that's coming out of it, you can see we get our humidity as well, because it's a temperature and humidity sensor, but also the ID, the name of the thing, all that jazz. Now with a little bit of JavaScript in there, we can then tidy that information up and get that message to present neatly how we want it. So instead of coming out as an 8.10 string, we can now get that to put out as float values, but get it as pairs with the right header data on it, basically, because we can then dump that straight into Influx and we're off and running. So I've planned out my drawing. I've got it all on the breadboard, kind of proved everything into the command line. How do we then go about making that all work? So this is the kind of my apologies if this probably doesn't read very well on anybody with anything other than a massive screen. We'll go through that in a bit of detail in a sec. This is the flow that's basically running on the weather station. Each one of these lumps is a different component of the weather station, and the gray modules basically are link nodes, and they basically push up to here, and then this then pushes out as an MQTT string, a data flow off here from this Pi2 off to the other one. So we'll just do a quick step through what's going on here. So this section at the top is the BME 2080. Now, thankfully, there's a really super node that somebody's already else has built that you can just import that into your node red flow, just address it correctly, hit the inject node, and bosh, just like the DHT22, you get all of the right information all wrapped up in exactly how you might need it to fall out the other end. It comes to a boatload of decimal points. I don't need that level of accuracy of quite how cold or wet it might be outside my house. So basically round that down to 2 decimal places, and then this RBE node here is basically a blocks any repeats. I was just trying to be super efficient about how much data, not that I've got how much data I push across the network, not that I've got any concerns or any limits on what I'm pushing here, but thinking of kind of taking this project on and turn it into a bit of an enterprise adventure. I don't want to unnecessarily be, I appreciate we're talking, nothing in the grand scheme of things here. This is specks of data, but just trying to be really efficient with it all. So hence there's a number of remove the repeats modules as we go through this. So that's that bit of the station. Next up is the DHT22 at the bottom. And again, just like the little video showed, inject, take the data, tag it, present it nicely, and then ship it out. Next up is the anemometer. So what's in there is basically a read switch. It goes tick every time you do a half a revolution of the anemometer. So what we've got in there, I've got a little counter node. So that's what the message hyphen speed is. And that's just counting how many revolutions that's doing per second. Then because we know what the circumference is, we can work out how fast the wind is going, and that's what happens in that little function node in there. So that particular function node there is a little bit of JavaScript that basically does that maths and spits that out as a meters per second value. I appreciate if you watch the BBC forecast, it's miles per hour, or might even be dealing with a Beaufort scale. But having come from looking at this from an automation and performer flying and theatre experience, we're generally concerned with is meters per second is what we're talking about, because our scenic pieces are moving at meters per second, and our wind that we're concerned about to keep it all in the same boat, we're talking about that in meters per second. These little green or kind of turquoisey nodes here would be the node red dashboard, so the local node red dashboard to this Pi, which was great when I was setting it up, making it all work. Could dial in and just make sure that was all doing its thing. Next up, slightly more complex, was the weather vane. So there's a resistor network and the underside of there. So that's spitting out obviously a different value depending on where the weather vane is pointing. That's been read into the A to D chip here. So basically I'm probing that every 10 seconds in this example. And that's spitting out a value from 0 to 1024. So there's a little bit of calculus in there just to try and round that up into the right place. Then what's going on in here is I'm just filtering out, and I appreciate we'll come on to questions and suggestions at the end. There's probably a much more elegant way of achieving this and making this a bit smarter. But basically what I've done here is filter that out. So I'm only getting the required values out. And then here I'm converting those values into cardinal points, so north, south, east, west, or a compass, 360 bearing, tagging them all up and then farming them all out. Then my rain bucket here, my nemesis of my weather adventure, very simplistic in its design. Obviously, it's just a water receptacle there. When it fills up, it tips back and forth. So I'm just counting how many tips there are in here. Now I spent hours trying to work out how to do a cumulative graph here. How would I add the math? I did a whole big convoluted flow of how to add the maths up to trying to generate a cumulative value of how much rain had fallen. It was about this point in the adventure that I was starting to look at Grafana. Obviously, all these kind of things run in tandem, and I was just like, actually, forget trying to do the maths here. The way to do it is to basically add up that cumulative ticker in Grafana. So all of this got as simple as it is now as you see it, straightforward there. Now next up was our UV sensor. Now obviously the pirates up in Sheffield do a super job of writing example codes that go with all of this. So I can make that work on the command line, but there was no, at the time, but I don't think there is at the moment, there's no dead simple node red node object to drop in that will just probe your UV sensor and output the detail. So what this particular module in here is, this is actually a Python function node. So you can dump or pop your Python code into there. So pretty much what I've done is taken the example code, banged it into there, and then we run that every 15 minutes and it outputs the values as it would do in the command line, which is just super, and then that farms it all off. Next up, and I think there's a lot of synergies here with the talk that Paul gave a couple of weeks back about his hanging baskets. So as I said, I had a bit of a nemesis, love-hate relationship with my rain bucket. Got it all working, sat here on my desk, and it was all working. Then I put it outside. I'm like, it's absolutely hoofing it down. Why is it not, my rain bucket not ticking up here? So I'd go out in the rain, open it up, and it would tip because it was, I'd been too keen, like a kid at Christmas, and just gone out there before the bucket was properly full. And I was just like, actually, I need to work out. And also, I'd be sat here looking out the window and it's like drizzly and horrible all day long. Why is that not a cumulative value? But obviously that receptacle in the rain catcher is just shy of 0.3 mil of water. So, even though it might be drizzling, you've got evaporation, and obviously that drizzle's got to land into the receptacle, and it's got to flow down the thing as opposed to get blown away, or I say just evaporate away. So I was like, right, I need to add in a precipitation, moisture, dampness kind of sensor. So, how damp is the air? Is it drizzly out there? And this actually came in really useful further on. So what we've got going on in here, and this was my workaround, as Paul discovered with the oxidizing and eroding the contacts on these. Every 30 seconds we turn pin 16 on. That's what's powering the reader for this. Give it a little beat to make sure it's all fully charged, and then I've just driven that into the second pin on the MCP 388, and then again, that's outputting a 0 to 24 value. So I've just remapped that to 0 to 100%. So we've got, when it's really wet, we've got a high percentage, and when it's nice and dry, a low percentage. Tag that, spit it all out. Because these are just the little units that you get from AZ Electronics. The it also the little controller board also comes with a GPO that's just closes as and when you broach a certain moisture threshold. Initially, I started to use that in here, but actually I just sacked that off because this is pretty stable and this is working really well. Next little moment on here now, I'm an audio guy by trade. That's kind of my bag. So I was like, right, I'm on the flight path. You know, quite frequently I'm getting a disturbed night's sleep. I'm getting woken up early. Is that because there's an airplane flying overhead, or is that just because I'm, you know, rubbish at sleeping? So I thought, what I'll do, I'll get myself a little microphone. I'll strap that onto my weather station, and then you know, it's just a dynamic microphone here. We get an analog voltage in here. I'll bang that straight into the A/T chip, and away we go. Obviously, the A/T chip here is looking for 0 to 3 volts. In audio terms, you know, a really good strong audio signal is just shy of 1 volt. So that's not going to quite work. Yes, I could get involved with some kind of gain stage along this yellow bit of wire here, but that I messed about with that, and I've got a bunch of other, you know, proper mic preamps and all that kind of jazz. So bonding all that together, but it just kind of basically brought the noise floor up. So I was like, actually, this isn't going to quite work. So in my kind of searching around, I came across this little inexpensive mic chip as well, which was great. However, for the life of me, I could not make it work back on my Pi Model B. Pretty sure when I started this adventure, I'd re-zeroed out the Pi and started afresh. But after banging my head with this for a couple of days, I reminded myself that actually I'd been doing some NeoPixel stuff with this Pi just before I started building the weather station. So I grabbed my kind of Pi Zero, initialized that, flashed it, made it all work. I was like, okay, right. So that's what's gone on there, because having been using pin 18 for the NeoPixels, it kind of messed around with what was going on there. I subsequently went in and zeroed out the reinitialized the weather Pi and just reloaded my Node-RED flow in it, and all was well. So that was all good. But the example script that comes with Adafruit to make that work, and there's a lot of examples of kind of using that to do little recordings, which is great. I wasn't interested in amassing, you know, hours and hours of recordings of airplanes flying over my house. What I wanted to kind of know was just like, is it loud or not? So I kind of searched around, didn't really happen across anything. But then I actually remembered my little trusty Environ unit, which has a noise sensor in it. So I'm like, hang on a minute, what was that doing? Because that one of the things that did was plot a nice little graph on the screen of how noisy it was. I thought, this is what I want. So as I say, just basically ripped off that example script, and I've actually dropped this in here as a exec node. So what this is doing is this is running the Python example script natively in the command line, just spinning that around as a JSON article after that, and then off we go. So what falls out here every time we run that is the amplitude of low, medium, and high, which is great, exactly what I want. So that's what we've got cooking all in there. So I've now got Node-RED running. I've got all my sensors coming in here, and they're all being shoved out over MQTT. Installing Influx and Grafana is super simple, thanks to this lovely chap, Mr. Simon Hearn. He's written an absolutely bomber guide of installing Influx and Grafana on a Pi and getting it working. I've followed this a handful of times now on various different things, and literally it's quicker than the time that I've been rabbiting on. So super straightforward. What that means is you then get yourself a nice GUI dashboard that can look something like this, or you can make it into whatever you want it to be, showing you the various metrics of, you know, what you've been monitoring, what's going on, and you can choose how long you want to monitor that for. Do you want to monitor the last 5 minutes, 10 minutes, hours, days, months, years, whatever you want to do. So it's actually great. Actually, I really like that, and I've used it quite a lot. And as I say, my little precipitation sensor, this is all badly rigged on the side of my lean-to, which actually is no longer there as part of all of this. because I say we can see here this was back mid-September time, and it was all of a sudden my BME 2080 stopped working. So I was like, okay, that's odd. I wonder what's gone on here. So the great thing about this, it's all time series data, so you can go back. So looking across this snapshot of time, we can see that we've had best part of 60 mil of rain. That's quite wet. And oh, hang on, stop the bus here. My sensor is reporting that it is 100% humid. Obviously my poor deteriorated bit of corrugated plastic and the way that I'd strung this up here, and must have been the way that the wind and the rain was coming in, had basically soaked my sensor. You know, it's 100% wet, and you know, it had been these orange, the yellow lines here show the bucket tips, and this green graph here is how humid it all is. So obviously it's got quite wet, it's got really wet, and it stopped working. So that was great to be able to ascertain exactly why that is, why I'd gone wrong. So next steps with where we're at, I'm kind of in the process of transferring the breadboard onto a bit of permaboard. I've got a really good friend of mine building me a Stevenson shield that I can hide the BME 2080 into. As I've alluded to there, I've knocked the lean-to down and I've built a new shed. So hopefully it won't all get soaked again. And also, actually, I've begun to quite like looking out the window and seeing the station there and seeing it's been round. You know, there's something quite nice about all of that. Question will be is whether the glass on the shed will block any of the UV. So whether that will affect my UV reading or not. I've also got a bit of a plan that I will use InfluxDB Cloud and Grafana Online to push some of that metrics data to. I'm quite keen that basically by design I can push some of that out and make it publicly available for those that might want it, might need it, or you know, transpose this over to some other projects where we might want to be able to remotely monitor certain values of stuff. And then also on the list, I saw a neat video of somebody had made a little lightning detector. I was like, that'd be quite cool. Obviously, we don't get a lot of lightning here, but I thought that'd be quite smart. And adding in pollutant or air quality monitoring. I've kind of looked into this, and what I've kind of seen is that it's either uber expensive to get something really solid and reliable, or it's still not cheap to get something that's perhaps not as reliable as you might want. So I'm yet to kind of take the plunge or get deeply involved in that. And the last little thing that I've kind of got on my list is to perhaps try and get that dashboard to kind of present a one-liner of what the weather conditions are. You know, you see on the weather app, it says that it's sunny today, or it's going to be wet, or it's going to be windy. Something that was quite nice about the Vantage View stations that I featured right at the beginning is when it was really windy, it would say, hold on to your hat, and or if it was absolutely chucking it down, it would say it's raining cats and dogs. So, you know, a bit topical. So last one is, this is the kit that I used, and this is in a nutshell the instructions. Dead straightforward to get it up and running. I've banged all the code and the diagrams up on my GitHub page. I'm sure Richard will feed these all out as well. The original project, Simon's Influx instructions, and then Node-RED, Influx, and Grafana. Anybody got any questions or any suggestions of what I should have done to make it bigger, better, faster, quicker, easier?
Can you go back to the previous slide?
Yeah.
I'm really impressed with this project, and it's particularly relevant to something I'm doing at the moment. I have solar power on my house, and I have an inverter which can charge the battery at off-peak if I want to, so it charges the battery off solar. But I can also charge it off-peak electricity. So at the moment it's on a fixed timer, so at about 3:30 to 4:30 it charges up the battery off a very cheap rate, and then it means that during the peak rate of the morning I don't use any expensive electricity off the grid. people have been working on a project using Node-RED and things like this with a Raspberry Pi and a Modbus adapter, so you can manually tell the inverter to charge the battery. And one of the plans is to look at the weather forecast, say, okay, when sunrise, is it going to be sunny, and charge the battery up more if it's going to be a miserable day, because you're not going to be able to charge the battery up until much later. So this has been really interesting. So thank you very much for this. It's been excellent.
Cool. Yeah, there's no forecasting in here yet. This is just kind of historic data, but I think that's how meteorology started, I think.
Yeah. So, but even knowing what the humidity is, you can then say, okay, well, it looks like it's quite wet. You know, it's been raining. It's quite wet. So therefore, there's a good chance that the sun won't come up until a bit later. So we'll charge the battery up more, because it's going to be a lot longer until you're going to have enough solar power to actually run the house or charge the battery, which can literally be in a difference of hours. On a really good sunny day, the battery can be charged by 10:30, 11. But if it's a miserable, cold, rainy, overcast day, then the battery may not even get fully charged by sunset, winter at 4 or 5 o'clock. So it really does make a difference, and this will save quite a bit of money, I think. Thank you.
Cool. I say I welcome to suggestions if I've made a catastrophic error along this journey, and anybody's got, there's a super easy way to do that as well.
What luck have you had with the DH22? Does that give you fairly good readings of the humidity?
Yeah, it's comparable to the BME 2080. It's not a million miles away from that. Admittedly, at the moment it's just set outside, so the sorry, on this one, the shed is the 22, and the outside is the 2080. So they are not miles apart in what they're doing, or they follow a consistent trend. I mean, none of this is calibrated, is it? So, but it's just trend recording. So.
And remember that the DHT 22, sorry, really got unstable after half a year or a year of usage, and suddenly you couldn't rely on its values anymore. And it's dirt cheap, of course. So yeah, it's you can just stick it in. That's why a lot of people just put it on the pin, so you can just rip it out and put a new one in. But I'd rather have a proper chip like the BME. I have another question. So you got a lot of valuable data now on your Raspberry Pi InfluxDB. How are your backups?
It's just a weather station. It's not going anywhere at the moment. But this was part of my plan about pushing some of it to pushing it to InfluxDB cloud. Would be where I wanted to try and get that.
You can do that from Node-RED. You basically just have two streams, one going to your local Influx and one to the outside.
Yeah, to be fair, I've not banged my head with it for a while, but I struggle to be able to get Node-RED to push to InfluxDB cloud. I couldn't work out that step. So if anybody's got any tips, please share.
I think there's a new exporter node went up last week or so.
Okay.
So yeah, because they're turning out new nodes all the time. But yeah,
absolutely.
There's been a whole bunch of Influx Grafana nodes. There's a Grafana exporter as well, which I have no idea what you do with that.
Yeah.
I think it does PDFs or something.
Okay. But obviously, there's, to an extent, Grafana and Influx are two competing houses. So Grafana kind of want you to push you into Loki and their other platforms or Prometheus. So again, I briefly looked at all of that, kind of ran out of not around the time, but I ended up banging my head with it a bit too much. I was like, do you know what, stuff this, I'll get the soldering iron out and do a little bit of that for a bit and then come back to the code.
Have you thought about trying to pull data off things like Bluetooth tags like the Ruby?
On the bigger dashboard that covers everything else in the house, there's some Philips Hue sensors that I'm probing the data out of. There's various other bits of kit that I've stuck pins in and seen what falls out, and that's now also been aggregated. Hence the idea of having effectively the weather Pi, which was the weather station, and then the main Pi in the house, which did all the rest of the aggregation.
Right.
I was wondering if you could feed all of this sensor data into something like Edge Impulse, which is one of the AI engines out there. and maybe then also use that as the training data, so it can reward itself for predicting the right kind of weather, and then it can become a forecaster somehow with all of that information.
No, I mean that would be a great step to take it on, and there's certainly my friends down at IBM are doing a lot of that kind of stuff. So it would be the whole AI thing is is the buzzword at the moment, isn't it? So
you can train it online in their cloud system and then use the models. I believe it's all free on the edge devices. So it runs locally.
Definitely.
As I mentioned in the chat, have you thought about trying to?
Oh, sorry, I've not missed that.
As I mentioned in the chat, have you thought about using an ADS BSDR box to detect flights overhead and identify them? And you correlate them with.
That's a good level. Obviously, I play with radios a little bit in my other walk. So yeah, something like that is probably an interesting thing to try and tag against the noise to say work out whether it's that which is the noisier one. So you can just kind of take this as far as you can, can't you? So it's endless.
Well, the nice thing you can do that with just the DVB-T dongle, so it's not a huge load on the system.
That would be interesting.
Thanks so much, Brew. We've got to move on.
Cool, pleasure. Sorry, I've
Thanks
overrun.
very much. It's very, very good. We like the anemometer. I should have one question. How did you put a pi into a floodlight? Is that what you were saying at the start?
Yeah, I kind of did that quite a little bit back in the day.
So what do? You take out the innards and then you put pi inside instead? Is that what you did?
Yeah. So strip out these were 6 years ago now. So yeah, strip out the halogen fitting, strip out the reflector in the back, and then just hot glue the camera module on the glass, hot glue the pi on the front, and then away you go. So you can bolt this up or cable tie it up to into the stadium. Just any old bit of nonsense, and away you go.
Yeah, I just think that's a really good idea for if you have a pi-driven security camera or something outside your house.
Yeah, I mean, yeah,
it's very innocuous. And
no, indeed. I mean, the rest of that picture is actually a big lighting tower above the stadium, so you wouldn't even notice that was there. And there was a couple of other floodlights around where this one was in this particular stadium. So, unless you were really looking for it, you wouldn't even notice it. And it's only ever there for perhaps 1 or 2 days of sport before we would roll in with the event, and then we own the stadium anyway. So,
right, very cool. Thank you very much.
Cool.
We've got Anthony talking about oscilloscopes. Anthony out there somewhere. It's hard to see everyone. Anthony, I know you're here somewhere. Oh, sure he joined earlier. Give me a sec. Does anyone else have anything they want to share at the moment while I track down Anthony? Just let me check my emails and stuff.
On humidity sensors, I was using, I think it's SHT series Sensirion, if I remember correctly, and that I was using those to measure humidity in a shed and outside to compare, and that was to build. That was a pi that was basically protecting the shed contents against condensation and damp, which has worked very well. It's a Pi 1 basically, and it's been running ever since the Pi 1 was a current Pi, and those have worked brilliantly. I mean, in particular, I think they were SHT 70 something or the others, and the reason I chose them is they're very accurate right to 100% humidity, which is what I was particularly concerned about. And they've run now for, it must be 6 or 7 years continuously, and have been fine. So they don't make that model anymore. I've dug out an SHT31 and started playing with it. But I did have to bit bang it at the time, although I think actually Raspberry's got some drivers for some of the newer models that humidity sensor.
And how close to 100% humidity do you get? Because obviously my my BME 2080 worked fine up until 100%, and then it stopped and never worked again.
Oh, it's gone over 100%. So if it's actually tipping down with rain or misty, it actually usually says something about 101%. Okay. But they can get wet, and they will survive getting wet. So it does say you might want to put them in an oven to dry them out again afterwards. But I haven't needed to do that. So. Nice. They were the SHT 70 series were expensive. They were around the £20 mark and the little £25 mark. There was one that was slightly lower accuracy, which I assume was just ones that came off the production line that weren't quite so, didn't quite meet the tolerance. But those particular ones went EOL, but they've got some newer ones now. The other slight disadvantage was they were proprietary interface. They looked like I2C, but with no addressing. So I had to bit bang them, whereas the newer ones are proper I2C.
Yeah, I mean that will help. All the components in there actually just bolt together, and the example scripts were all there. So it actually assembling it all, putting it all in was pretty easy.